my name is Rich Howard, owner of Architectural Builders Supply, and this video is to attempt to replicate a door pull that a client sent to us. I saw the photos and I immediately realized, well, this is going to be 1960s, would be my best guess in terms of a vintage. Okay, so here we are. We're ready to start our air. Roll that in slowly. Now we've got the combined power. That means that our tanks are actually rather low. Let me show you my other compressors, which I have previously. There's two stuck down in here, and there's two up over here, and they're all connected to this giant tank. So the compressors are going to kick on. That's about the threshold when they're going to turn back on. So that PSI valve, you hear them, is going to it's going to move up much closer to 40 as those tanks start to fill. So as soon as the tanks turn on, there's a little dip, or what happened was the auto, I'm drawing a blank, what ejects the water out of the bottom of the tank. Auto drain? Something else turned on over there. Around that. Okay, so the air's on. Now we got to turn our spindle on. And I've got Chris Burns coming, and I'm gonna figure out a way to visually see if the spindle is on with a light. I'm hoping that we can do something in the software and then some sort of a light that we can wire into the control box. Now we're gonna go over and tell it, yes, please. And another thing I'm going to do is I'm going to add a keyboard down at the business end so I can hit that space bar a lot faster. Good sound. Yeah, it's looking good. I'm not a fan of how much we've increased the feed rate vis-a-vis the spindle. I don't like the sound. I don't like the quality of the cut. We're just going to have to continue to learn. Thinking to yourself, we're going to have a problem on this area here. So we're literally going to have to go through and just punch an area out, because when the feed bit completely exits this area, we've got to really move it off because of the 120 degrees. So we're going to have to do another pass of just cutting all of this out. because I don't want the V-bit hitting two sides of aluminum at the same time. You can really hear it strain under that pressure. Direction. We should be going counterclockwise, and I've just kind of walked back to the tool and realized we're going. And I don't like all the sound that it's making. I also feel there's more vibration in the workpiece itself, which is certainly not good. Its direction and see if we get a little different result. So here's what we're going to do. We're going to pause the work. Pardon me. We're going to stop the work. We're then going to change our start depth to this. And then we're going to change the... It doesn't sound good. We're going to change the direction. So let's do that. I'm going to stop this video. Yeah, it's no good. Let's do that.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, so I have changed the direction, but I've also set the start depth at 0.04 and then the cut depth at 0.075, I think. So let's get us back up and running. Our air is on. I can hear the spindle. We're going to hit OK. I'll explain what all this is at some point. That's a better direction for the outside cut because the bit is turning clockwise, but I'm pulling away so that the chip load is big at the initial cut. Because the spindle's moving away from it, it gets smaller. So you can even... It may be my imagination, but I don't believe the screeching is... It may not be as bad. Let's just let it run. Sound is not so awful. convinced that the quality of the cut is better. Much cleaner. Our path depth hasn't changed. Our spindle RPM hasn't changed. Our feed rate hasn't. I'm not convinced that this piece of material is consistent. tantamount run. Yeah, we're at our depth. So let's see what this is going to look like. Okay, so things get a little bit quieter. Let me turn off the air going to the tool. I should say the cold air gun. Right. Let's move the Z carriage out of the way. MX90. Okay, so assuming our math is correct, we're going to have plenty of room here for our V-bit. Let's grab that V-bit and do a reality check on it. 37-92. As long as that dimension is greater than 1/4 inch, where the tip of my finger is. Now, what we've got to do is we've got to come over here. So we're going to have to now figure out how far over to come to open this up so that when our bit is doing its job, it's coming off far enough. I don't want to bevel this end. At least on this project, for this door pull, I don't want to bevel that end. So we're going to have to exit off the workpiece far enough where all this is going to be opened up. So we're going to now switch back to the software, and we're going to figure out how far over we've got to just come out with a pocket tool path in this area on both sides. The issue though is I didn't account for having to do that with the dust boot on and not hitting the clamps. We might have to remove one of the clamps on that side. I'm not super concerned about it, because just for that, obviously we'll do those vectors one at a time, those pocket preps one at a time, so I'm not concerned about, I'll be repositioning the clamp is what I'm trying to say. All right, let's move on back to the screen.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, now let's go back and figure out how much room we're going to need on this 120 degree. And we kind of have it already here, which we absolutely have it. Okay, so we need to figure out how far we need to pocket that out, and that's basically going to be all of this plus a margin.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.